Hello, everyone, and welcome back to Beyond the Business. Over the past months, we've been hearing a reassuring message. The Antarctic ozone hole is shrinking. It is smaller, it closes earlier. The data confirms a long term recovery trend. And this is real progress. The Montreal Protocol remains one of the strongest examples of global cooperation based on science. It worked because the problem was clearly identified, the source was known, and action was taken before irreversible damage occurred. But today, I want to pause on a different question. Not whether the ozone hole is recovering, but what this recovery does not automatically protect us from. Because the ozone layer is not a single problem that can be switched off and forgotten. It is part of a living atmospheric system that continues to evolve under new pressures. When we talk about ozone, we still tend to think in terms of holes, that they appear, closes, and end of story. But scientifically, that is not how ozone behaves. Ozone depletion does not appear as a dramatic gaps. It's persistent thinning and chemical imbalance, especially in the lower stratosphere. These changes are quieter, they don't make headlines, but they does matter. If we look at global ozone maps today, a different picture emerges. In several regions across the mid latitudes, ozone concentrations remain consistently below historical averages, not collapsing, but suppressed. One of the most documented areas is East Asia. Over eastern China, the Korean Peninsula, Japan, and the Western Pacific, scientists observe recurring ozone deficits in the lower stratosphere. These are not caused by classic ozone depleting substances like CFCs, those were largely removed decades ago. Instead, the drivers are chemical. High concentrations of nitrogen oxides, volatile organic compounds, and short lived halogenated substances. They all interact with the sunlight and atmospheric circulation. These compounds don't punch holes in the ozone layer, they all alter the chemistry that allows ozone to form and persist. This is not an accusation, it is a systemic effect of dense industrial activity interacting with the atmosphere. A similar pattern appears over South Asia. Here, rapid industrial growth, coal based power generation, transport emissions, and large scale biomass burning create a paradoxical situation. Near the surface, ozone levels increase, becoming a health hazard. Higher up, ozone formation is disrupted, leading to thinning in the lower stratosphere. So the system is not breaking, it is being reshaped. In the Middle East, high nitrogen oxide emissions from petrochemical industries combine with intense solar radiation. The result is highly reactive atmospheric chemistry that suppresses ozone concentrations seasonally. Again, not a hole, not a collapse, but a signal. Even regions far from industrial centers are not isolated. In the southern hemisphere of Australia, southern Africa, and parts of South America, ozone variability is influenced by changes in atmospheric circulation. Air masses transport chemical imbalances across long distances. Climate driven shifts in circulation patterns amplify these effects. This is an important point. Ozone is a local issue, it is distributed system. There is another pressure that did not exist when the ozone problem was first identified. Human activity in the upper atmosphere. Rocket launches are increasing rapidly. Satellite constellations are expanding. Each launch injects exhaust gases directly into sensitive atmospheric layers with the nitrogen oxides, water vapor, particulate matters. These emissions bypass the lower atmosphere entirely. The science here is still developing, but the direction is clear. We are introducing new chemical inputs into regions of the atmosphere that were previously untouched by industrial activity. This is not catastrophic, but it is cumulative. What connects all of this is not failure, it is success followed by complacency. We solved a very specific problem, the uncontrolled release of ozone depleting substances. And in doing so, we proved that we coordinated global action can work. But the system did not freeze in time when we succeeded. Industrial activity evolved, energy systems expanded, transport intensified, climate dynamics changed. The ozone layer recovered inside a very different atmospheric environment. This is where the uncomfortable thought emerges. We like to tell environmental stories with clean endings, problems identified, solutions implemented, case closed. But Earth systems don't operate in chapters. Recovery in one dimension does not cancel pressure in other. Success does not mean stability. What we are seeing today is not the return of the old ozone crisis, it is something subtler. A system that is recovering globally but under constant regional stress. A system that is monitored less closely because it is considered fixed. A system influenced by industrial chemistry, climate feedbacks, and new technologies operating beyond existing regulatory frameworks. So, the real lesson of the ozone story today is not about victory, it is about vigilance. We fixed yesterday's problem, but the atmosphere did not stop evolving. And as we expand energy systems, industrial output, and even space activity, we quietly introduce new pressures into layers of the planet. They were never designed to absorb them. The question is no longer whether we can solve environmental problems. The question is whether we are prepared to keep watching the systems we believe we have already solved. This was Beyond the Business, and thank you for listening.